All right, mathletes. So today I want to do a quick video highlighting, critical Z scores versus critical T scores, or critical Z values versus critical T values, and when to use them. All right. So we've gone over hypothesis testing, we've gone over confidence intervals. Um, and there's so many different pieces that I kind of just want to do a rewind and break these up into chunks because I still see some confusion going on, right? And regardless if you're in my class or not, I know this will be valuable to some people, kind of clarifying some things. All right. So let's say they wanted you to construct a confidence interval. All right. And here's our formula here. I'm kind of pointing it out down here. You can see my mouse. Um, so we have this formula. Notice one of these things that we're going to need to find is our critical value. In this case, our critical Z value right here. And whenever you see the Z and then the subscript is alpha divided by 2, that just means you have two tails, all right? So you could kind of ignore that alpha divided by 2, and we're just finding the Z. And right now, what I want to focus on is how to find this using our TI-84 calculator. And if you want to see how do you do this using the table, just let me know, comment below, and I will make another video for you. All right. So again, I want to make sure all our mathletes have these videos. So please like this video and subscribe because I think these are very helpful, the responses I've been getting. So just do that so it could kind of go out to more people if you will do me that favor. So check this out. To get the critical values, we're going to go ahead and hit second vars, right? And that gives us the distribution, this blue button in my calculator. Yours might be different. And then I'm going to go down to inverse norm because I want the Z. So make sure in your notes here, put inverse norm. It's inv norm, but I call it inverse norm, all right? And the area, we're going to put that area, and we got to be careful here because on a lot of your calculators, it's going to say left, center, and right. So if your calculator is a little older, like myself, this calculator, what I'm going to do is I'll pick the area of the left tail. So my calculator is not as nice as yours, most of yours. So I don't have that option. So I'm gonna have to put in the area of one tail. And so when I'm drawing this, notice, let's say I have 90% confidence, or 5% confidence level. Right. So let me just draw a quick picture for you, just so you know what the heck I'm saying and make sure it makes sense. So if I draw a quick distribution here, and if this middle is 90%, right? That means the tails, that's a 90, it looks like 96. That means the total tails is the remaining 10%, right? But there's two tails, so what I'm going to do is take that 10% and I'm going to divide it by 2. So that's where the alpha divided by 2 comes in. That's where this comes in, alpha divided by 2. So this is 0.05, which is 5%. So that means that each one of these tails is 0.05 and 0.05. All right. So that's using this calculator. For those of you that have the nice calculator where you have that center option, just put that 0.90 and then use center. But again, my calculator right here, it doesn't give me the option. So here, I'm going to put 0.05. And then notice this is a standard normal curve. So this is always 0 and 1. And I'll go down and hit paste. All right. And then I hit enter. And that's going to give me that negative and positive, because notice it's left and right, negative positive 1.645 if I round. So that's where that critical value comes. And a lot of you guys have nice tables. Maybe your instructor has provided you with some values that are common. They keep coming up over and over. All right, so this is if we're looking for the critical Z-score. So again, if you're doing, say, population proportions and trying to find confidence intervals for them, you would use the same thing, right? You'd find the Z-score. So it's the same method. So now what happens when we're looking for a T-score? Okay, so let me highlight that. So for a t, you're going to need not only the percentage like we have here, that 90, but you also need a sample size. So I'm going to pretend our sample size n is 25. So check this out. So now to find the inverse t, or the t-score, we're going to go to second, and then we're going to go to distribution, and now we're going to go to inverse t. And now look what it's going to ask me for the same thing. So I want the left tail. So again, on this calculator, it's always asking for the left tail. If you have the modern, actually, even on the modern versions, the more updated one, they don't give you a left, center, or right option. So in this case, you're gonna have to draw out the curve, unless you can do it in your head, and then give me the left tail. All right. And let's see, degrees of freedom. I think I said 25 is our n. So it'd be 25 minus 1. Yes, you would just put 24 there, but just to highlight that fact. So again, this 25 here might wonder, where's that come from? So here I'm pretending the sample size is 25. Okay. Hit enter. And it's thinking. And so I would get 1.711. So that would be this value, my critical value, right? And again, if you're using, say you're doing a hypothesis test, and you would be doing the same thing if you're using the formulas to get your critical value. All right, you'd be doing the same thing we just did. So how do you know when to use what? Well, remember, when you're looking and given a standard deviation, you're asking yourself, if the standard deviation comes from the population, right, then you're going to use, boom, the z, inverse norm. You're going to find the critical z. But if your standard deviation of the population, sigma, is unknown, all right, then you're going to go ahead and use this one right here, which is inverse t. And sorry for the delay. I was just looking at this and there's an error, because look at this note that they have here in the summary. It says, then the confidence interval for the population mean is this, if the population mean sigma is unknown. So if the population standard deviation is unknown, is known, excuse me. So there should be standard deviation, but that's okay. We all make mistakes. All right. So that is what you're looking for. So again, the T goes when sigma is unknown. So they'll give you a sample standard deviation, but you will not know the population standard deviation. And that's when you're going with the T. And if you know the population standard deviation, which is sigma, then that's when you're going with inverse norm, which is your Z. Okay, so that's how you distinguish between the two when you're looking for those critical values. All right. And again, if you want to see how to do this using your table, just again, let me know. And I hope this is helpful, mathletes. All right. Have a wonderful day. Talk to you guys later.